Hey, what's up? This is Mr. Bainey, and this lesson is 7.3 Linear Inequalities in Two Variables. And the essential question is, how do you write and graph linear inequalities in two variables? This lesson is going to take a lot of different skills and things that you learned throughout this year. And so this could be difficult for some of you, and it's going to be good practice with some of those skills if you haven't mastered them quite yet. And so skills like graphing lines, um, also looking at inequalities, knowing how to write inequalities as well. So this explore activity is something that I'll kind of leave up to you if you want to practice some more. There are a lot of vocab words that you see highlighted on this first page. I'm not going to go into detail of what they are right now. If you want to read through them, go read through them. I'm going to mention them in some way as we're going through some of the examples. On page 325, we're going to do B here. So we're going to graph a linear inequality. So you'll see that our linear inequality that we're starting with is this right here. And so to graph this, you're going to want to imagine that you're graphing the equation. So if you get rid of that inequality symbol that's there, what is it? Negative 14 plus 2y is less than negative x. And instead think of negative 14 plus 2y equals negative x. So the first thing is, can you graph this function, this equation? And so there's lots of ways. There's x and y intercepts. You could do a table of values. You could solve for y and do slope and y-intercept, whatever you want to do. Now, I'm going to follow the steps that are here on the left side. You could, or in fact, I might even do it on the right side as well. So we're going to solve it for y. They're going to put this into slope-intercept form. Because slope-intercept form, I believe, is probably the most efficient way to graph a line. So the first thing we're going to do here is add 14 to both sides. So we're going to get 2y is less than negative x plus 14. Then we're going to divide both sides by 2. And so when I divide both sides by 2, I get negative, then negative 1/2, right? Because x over 2 is the same as 1/2 times x. And then plus 7. So I'll show you on the right side if this were an equation, what it would look like, and it would pretty much be identical. So I get 2y equals negative x plus 14. And then when I divide both sides by 2, I get y equals negative 1/2 x plus 7. So now, are you able to graph this? Y equals negative 1/2 x plus 7, because that's going to be crucial in doing graphing a linear inequality. So we call this equation, we call this the boundary line, if you can graph it. Okay, this is the vocab word that's mentioned on the first page. So we're going to graph the boundary line. It tells you that in sort of this next part here. The inequalities uses the symbol, this symbol, which is less than. So we're going to use a dashed line to show that the points on the line are not part of the solution. So remember that we have less than, and then we have less than or equal to. The less than means that that number, that if they're equal to, it's not part of the solution to the inequality. Yeah, if it was equal to, that means that those numbers would actually be solutions, but we're only looking at strictly things that are less than. So if we were to graph y equals negative 1/2 x plus 7, that means we're going to start at 7. So 7 is, and this thing is going to try to trick us a little bit because it goes by 2's. So 7 is about there, and I'm going to go down 1 and over 2. So if I go down 1 over 2, remember this thing goes by 2's, and don't get tricked. And the line is going to be going through those 2 points. So imagine the line going through those 2 points. And let's make a note here, actually, that if it's less than, if it's greater than, it's going to be dashed. Okay, write this down. So it's a dashed line. If it's less than or equal to, greater than or equal to, it is a solid line. Think like continuous, like drawing a continuous line. It is continuous, so that means dashed. This is less than, so it's dashed. So it looks something like this. Make sure it's very clear that it's dashed. Let me draw my arrows. Okay. The next part of this is we're going to shade the appropriate part of the graph. Since the inequality uses the symbol less than, we're going to shade, think about less than. As long as this only works if it is in slope-intercept form. Okay, so let me write this down. Only works if in slope-intercept form. So think about what less than means. I'm either going to shade, take a look at the graph above. I'm either going to shade above this line, so everything up here, or I'm going to shade below. So if we're thinking about what less than means, it would make sense. It'd be obvious that we would shade below, because below sort of is the same as saying less than. So I'm going to regraph it here. So remember, starting at 7, going down 1 over 2. I got my dashed line. And we're going to shade below the boundary line. So something like this. If you want to, make it look all nice, you can, shade it in all the way. But what this is really telling us is that, let me actually shade in this whole thing so you can see it. So this whole thing here, everything here is our solution. And what I mean by a solution is that I can take any point that's below this line and plug it in, and it should be true. So the way we can check our solution is, let's pick some points. So take a look at this table. The easiest point to test is the point 0, 0. So look at where 0, 0 is in the graph. It's right there. It's right here. So according to what we shaded, is 0, 0 a solution? And it is. It's in the shaded part. So this needs to be a solution. It needs to be true. So this is below the line, the boundary line. And if I were to plug in 0, 0, it is negative. I want to know, is negative 14 plus 2 times y less than negative x. So for x and y, I'm going to plug in 0 for both. And of course, they don't give us enough space here. So in that little box, I'm going to write down negative 14 plus 2 times 0 is 0, right? Is that less than 0? Oh, yeah, it is, right? Negative 14 is less than 0? Yeah, that's true. So if that's true, that means 0, 0 is a solution to this inequality. All right, so 8, 8 is up here in this non-shaded part. So this is above the line, which means I better get something that's false. So 8, 8, which means for x and y, I'll plug in both 8s. And then I'm going to get, what is this, negative 14 plus 16. Is that less than negative 8? So I got to do a little more math here. 2, is that less than negative 8? Looks like it's not, so it's false, which means that 8, 8 is not a solution. So just to recap this whole thing here, We drew our boundary line, remember? However you need to do that, slope-intercept form I think is the way to go, and it's a good way to practice if you're not good at it. So draw your boundary line, figure out if it is dashed or solid, right? This is why we wrote this up here. If it's dashed or solid. And then you're going to figure out, do you shade below or do you shade above? And it's always good to test some points if you need to. So when you shade it, the area you shaded, these are all solutions. We have a ton of solutions here. You can test any of those that you want. You can test the point 1, 1 or 2, 2, or I don't know, -4, 0, any of those that are in the shaded region. And then the ones that are above, these are non-solutions or not solutions. Okay? Let's take a look at the examples here, page 326. I'm going to do number 3. I would like you to try to do number 4 before you see my solution. So number 3, I'm going to solve it for y, put it into slope-intercept form. So I'm going to subtract 3 on both sides. So I'm going to get negative y is less than negative 5x minus 3. So the next thing I'm going to do, so here is something you have to remember about inequalities. If I divide by -1, in fact, if I divide or multiply by any negative number, this needs to switch. So it's going to become y is greater than 5x plus 3. Okay, so at 3, here is my y-intercept. I'm going to go up 5 and over 1. So now before I draw my line, because it is greater than, that's going to be dashed. So it's going to look like this. Draw it all the way through the graph, by the way. Please do that. And because it's greater than, I am going to shade above. Above, so if I just choose any point on the line and go up, that is the section I'm going to shade. Okay, so everything in here is a solution. Everything below the line or to the other side of the line is not a solution. So if I try the point 0, 0, whoops, that's not what I want to use. 0, 0 is not a solution based on what I've graphed, right? So if I plug in, let's see, it would be 3 minus 0 is less than -5 times 0. If I plug it in, so this means 3 is less than 0. Is that true or false? That is most definitely false. So that checks out. 0, 0 is not a solution, and it is not shaded on my graph, which is a good thing. So if I wanted to try, I don't know, the point, we want to try to pick an easy point, yeah. So let's do, there really are no easy points in this shaded region. So -2, 4 should work for us. So it'd be 3 minus 4. Is that less than -5 times -2? Okay, so make sure you plug in the right numbers for x and for y. So I get 3 minus 4 is -1. Is that less than 10? Yes, that is true. Okay, so you'll definitely want to get in the habit of checking points. Really, you could just, checking one point is enough, because if you check one point in that area and it's a solution, that means all the points you check in that area should be solutions, and all the points you check in the other side are not solutions. So checking one point really is enough, but checking 2 is almost like you're verifying. So some of you I know like to check your answers quite a bit, and so looking at more points is always a good idea. Okay, number 4, please pause it and give number 4 a try. Okay, I'm going to solve for y, and let's subtract 10x on both sides. And I'm going to get 8y is less than negative 10x plus 64. When I divide both sides by 8, I'm going to get y is less than negative 10 over 8. That ends up simplifying to negative 5/4 x, and I get plus 8. Right? Remember, dividing everything by 8. Okay, so my y-intercept is 8. So let's graph our boundary line. And I'm going to go down 5 and over 4. That's my rise and run, remember. So here's my boundary line. It is dashed. Remember, it's solid if it has the less than or equal to or the greater than or equal to. It's less than, which means I'm going to shade below. And then this time I'm only gonna test 1 point. And the easiest point to test, 0, 0. Let's do that. So I'm going to go straight to I always like to go back to the original equation, original inequality that's up here when I'm testing points. Because sometimes you'll catch mistakes there, especially if you think you made a mistake in writing your slope-intercept form. So the point 0, 0 is going to be 10 times 0 plus 8 times 0. Is that less than 64? And so it looks like it is. 0 plus 0 less than 64. That is true. And you'll see that 0, 0 is in the shaded area, which is a good thing. And so that my answer checks out. Okay, and let's take a look at just the last page here. And number 5. Oh, actually, part B, just taking a look at that. You'll want to be able to write the inequality as well. So the slope of this line, let me first point out, the inequality is already graphed here. You see it's dashed, you see it's shaded above, and there's the boundary line. So in order to write the inequality, we need to know what the slope is. So let's find a nice point here and also here. So our slope is, this thing went up. Looks like this counts by 2s still on the x and the y. So it went up 2, 4, 6, 8, 10. And it went over 6, something like that. Sorry if that's a little hard to see there. It went up 10 and over 6, which means, excuse me, our slope is 5/3. Okay. Oh man, the y-intercept, let's see, up 1, 2, 4, 5, and over 3. Okay, the y-intercept here is very, very tricky. If I were to give you this on a quiz or a test, I probably wouldn't make it this tricky. So we'll work with it still. I'm not going to do the y-intercept quite yet, or even the boundary line. But on the 4th line here, it says the boundary line on the graph is blank, and the shaded region is blank. The graph, so the symbol will be blank. So we can fill this out. The boundary line is dashed. The shaded region is above the graph. So those two things put together tell us the inequality symbol. So the inequality symbol is going to be greater than, because that's above and dashed. So we know it's going to be y is greater than 5/3 x plus something. Now this something, I'm just going to, just for the sake of trying to estimate it. And so estimating this is totally fine in this case. But if you can try to make it accurate, please do that. So, excuse me, the y-intercept looks like it's just above 3. So let me just say it's let's just say it's 3, because it looks like it's pretty close. I don't think it's exactly equal to 3, which is fine. It's probably 3 2/3. So it's 5/3, y equals 5/3 x plus 3. And so now I can erase this here and put 3, and that's our inequality. Okay. Number 5 and number 6, as I'm going through these, if you want to try to pull ahead of me and work on them yourself, please do so. It's going to help you think about them a little bit better. And I'm not going to do all of it anyway. So number 5, complete the linear inequality that represents this relationship shown in the table. So what you need to know is that all of these are solutions. They're all solutions to the inequality. So if x is -3 and y is -8, I could say that -8, how does that compare to 2 times -3? And 2 times -3 is, sorry, let me erase that. 2 times -3 is -6. So how does that compare? Well, -8 is actually smaller than -6, right? If I plug in -10 for y and -2 for x, I get 2 times -2, which is -4, and that one is smaller. So I could test all of them, but it looks like it's going to be this inequality. You know, double check the rest of these if you want to be sure. And also, it looks like it has 0 zeros. How does that compare? Right, it's going to be equal to. So it looks like it might actually be this symbol. Sorry, this is really sloppy here. It's going to be less than or equal to, it looks like. Okay, but again, you can double check all of those points there. Number 6, Ramona has $18 that she can spend on food for her dog. Dry dog food costs $5.50 per small bag, and wet food costs $2 per can. So we're going to write a linear inequality that describes how many bags and cans of dog food Ramona can buy. So our unknowns are, we can choose x and y, that's fine. X can be the number of bags of dry food, and then y can be the number of cans of wet food. And so we know the price of each one, and we know how much she can spend. So I'm not gonna completely write this whole inequality for you. Inequality means you need to have an inequality symbol. So it's important that you don't put an equal sign in this. And I know some of you tend to do that. So if I were to take the total price of the dry food plus the total price of the canned food, we know that that's going to have something to do with the 18 bucks that Ramona can spend. So you want to think about, can she spend more than 18 bucks or less than 18 bucks or equal to 18 bucks? And that question is going to help you with determining the inequality symbol. And so she can't spend more than, she can spend less than or equal to, so it's going to be this symbol right here. Okay, so I'll let you finish that one up. This is the last lesson of the module, so one thing you'll want to also do after you're done with going over this lesson and doing the practice problems is to go back and look at modules 5 and 6 as well. In addition to the 7.1 and 7.2, there will be a test coming up soon on this. Okay, thanks for watching. Have a wonderful day.